Hello, good morning, Year 6. Welcome back. I hope you had an awesome long weekend. We are going with mathematics first this morning, as always, and we're going to be looking at problems involving area today. But to get our brains working, there is a Numeracy Ninjas challenge on Kahoot this morning. So go and have a go at that, get your brain warmed up and ready for today's session, and then come back and watch the rest of this video. Remember, whenever you're watching these videos, you can pause them. Okay, have a go at working out the solutions to the problem yourself before you then, press play and work through your answer with me. So, first of all, a little question for you to think about. What do I mean by perimeter? Well, of course, that is a distance around the shape. So, for example, if this was 3 centimeters, 4 centimeters, again, not to scale, 3 centimeters and 4 centimeters, of course, I would just add them all up, or I'd add two sides up and times by 2. So 4 plus 4, okay, because that's that distance here. 4 plus 4 is 8, plus 3, the distance here, is 11, and then here as well on this bottom side is 14 centimeters. So the perimeter is equal to 14 centimeters. That is a distance around the edge of the shape, okay? And that would work for any shape. Now then, what do I mean by area? Well, that is the amount of space inside the shape. So what is inside here? Okay. So how do I find out the area of a rectangular shape? Well, of course, I just times the length by the width. Again, you can see there the formula A equals LW, which basically means area is equal to the length times the width. Remember, your answer will always be squared, whether that is centimeters squared, kilometers squared, millimeters squared. Okay, whatever the unit of measurement is will then be squared at the end. So let's have a look at solving this one first. What is the area of this shape? Well, it's a rectangular shape, so it's just area equals length times width. So area is equal to LW. So the area is equal to 6 times 3. The area is equal to 18 kilometers squared. Okay. Number 1, done. Easy peasy. Well, let's have a look at this one here. Compound shapes. Now, the same thing is they're both rectangular shapes, so I'm going to keep my same formula. Area is equal to length times width. But I've just got to be careful, because if I do length times width, if I was to do this 3 by 3 here, that would work out all of this as well, and I don't want to do that. So I'm going to split this into 2 shapes. Okay. So I have now got, again here, I've got shape A. I'm going to call this shape A, and this one B. So I can now work out the area of A is equal to length times width. Well, that is 3, that long side, multiplied by 1. So area of A is equal to 3 times 1. So the area of A is equal to 3 meters squared. Let's look at shape B. The area of B is equal to, I've got to be careful here. It is not 3, because 3 is from here to here. That's the whole way across. And it's not that I'm trying to work out. It will be 2, which is from here to here, times 1. Okay, so 2 times 1. So the area of B is equal to 2 meters squared. So the total area of this shape is equal to 3 plus 2. So 3 meters squared plus 2 meters squared, which is equal to, of course, 5 meters squared. Now, there is another way that you could have done this. You could have done 3 times 3 and then minus sort of this area out here. Okay, that would have worked. But I just prefer it. It's much, much straightforward. Just split it into 2 shapes, A and B, and then work out those shapes and add them together. So the total area of that shape there is 5 meters squared. Okay, so let's have a look at a little bit more of a tricky one here. So I'm now going to look at a compound shape, but with missing lengths. Again, they're all rectangular, so I can use the same formula, length times width. But I've got some missing. But before I go that, I'm going to split mine into different sections. I'm going to go down here and down here. I've got shape A, B, and C. So let's start working out the area of A. So the area of A is equal to length times width. So the area of A is equal to, Well, I know 2 times by what? Well, I've not got that there, so I'm going to have to fill that in. So this side here, because it's the whole length, is the same as the other side. So that is going to be 5 centimetres. Just 2 times 5. So the area of A is equal to 10 centimetres squared. Well, let's look at B now. Okay then, so B, I'm going to be working out is from this here to here, which is not 7 centimetres, okay, because 7 centimetres is the whole way across. And I need to work out the height from, again, I'll have to just switch to a different colour so you can see that one there. So that would be from here to the bottom here, which is not 5 centimetres because it's not all the way up. So the bottom one here, well, I know that 7 all the way across, if this is 2 centimetres here, this must be 2 centimetres here. So this gap in the middle must be 2 centimetres plus 2 centimetres, 4 centimetres. Minus that from my 7 centimetres along the bottom would leave me with 3 centimetres. And of course, that is already there for me. Okay, so it's 3 centimetres. So the area of B is equal to length times width, which goes to 3 times, what is the height? Well, if it's 5 centimetres for the whole thing here, and this is 1, that must mean that this one left, okay, here, from that to that bit there, would be 4 centimetres. So it's 3 times 4, which goes to 12 centimetres squared. And C, 2 centimetres times 5, since I can work that out, so the area of C is equal to length times width. So the area of C is equal to 2 times, again, 5 again here. So the area of C is equal to 10 centimetres squared. So I've worked out A, B, and C. So the total area is equal to 10 centimetres squared plus 12 centimetres squared plus 10 centimetres squared, which of course is 32 centimetres squared. Okay then, and there we go. I've worked out my total area. Again, another way you could have done this would be to do 7 times 5 to work out the whole area, and then take away the area of this shape here, which would be 3 times 1. So that'd be 35 minus 3 is equal to 32 centimetres squared. Okay then. Triangles. Let's look at the area of triangles. Well, area of a triangle is half of the base times the height. Now I've got 2 triangles here, and to make that, see why that works, if this was the height and this was the base, okay, height and base, if I multiply them together, that would give me all of this area here. But I'm working out a triangle, which is half of this. So as you can see, it's a very similar formula, okay, to a rectangle to a square, but I would half it because that would give me the half size there. So let's have a go at solving one of those problems. Area is equal to half of the base times the height. So again, my formula is the area of a triangle is half b times h. B times h is in the brackets because I would do that first. Now be very careful here because you can see it as 3 units of measurement. So I do not need this 5 here because it's not the base or the height. It's the distance across from corner to corner, okay? So I'm not going to be using the 5, I'm going to be using the 3 and the 4 because that's the base and the height. So the area of this triangle is equal to a half of base times height, which goes to a half of 3 times 4. So that's 1/2 of 12. 3 times 4 is 12, and a half of 12 is 6, in this case centimetres, and again squared, area of a triangle, half of base times height. Ooh, compound shape now of squares and triangles, and again I'm not missing unit measurement, but it's not exactly clear there, so be very careful. I would split this into my 2 shapes, and of course I'm going to have a square and a triangle. And that will leave me with something like that. So I can just split these apart just very slightly so you can see that there is a difference there. So the whole distance along this bottom is 8, but I'm going to label this as shape A and shape B. Now the area of A is equal to, well, it's a square, it's quadrilaterals, it's square or rectangle, so it is just length times width, which would be area of A is equal to 3 times 3, which goes to 9 centimetres squared. And for B, well, I've now got to work out what this is here, this distance. Well, let's have a little think about that one. If we know that it's 8 centimetres all the way across and the square here is 3, it must be 8 minus 3, which must mean that this is 5 centimetres. The height is obviously 3 centimetres because it would be the same height as the side of the square. So the area of B, which is a triangle, is a half of base times height. So that goes to a half of, in this case, 5 times 3. 5 times 3 is 15, so it's a half of 15. And 1/2 of 15, well, that would equal to 7.5 centimetres squared. Have I finished? Of course not. I now need to do the total area. Total area is 9 plus 7.5, both centimetres squared, of course, which would equal to 16.5 centimetres squared. Voila. Compound shape involving squares and triangles. Final one. We're going to be looking at parallelograms. So the area of a the area of a parallelogram is equal to base times height. So again, my formula is here an area of a parallelogram is being difficult to pronounce today. The area of a parallelogram is equal to base times height. Now, if you want to see how that would work, well, it's just base times height, and you might be going, well, that is just that times that. What about this bit here? Well, of course, if you think about it, it's going to work out that bit there, which is going to work out that bit there. So effectively, I'm just moving this part to the side, and it would make a normal quadrilateral. So you just need to make sure it's base times height, okay? Not the side length, it's base times height. So let's have a little look at this one here. You can see that this is 7 centimetres going down, but that's not what I'm going to be trying to work out. I need to do base times height. In this case, the area of the parallelogram is equal to base times height, which would be, the base is 10 centimetres, times the height of it is 6 centimetres. And again, if you visualise this one, it would be like this part here, this triangle would be moving across to this bit here, effectively making myself a quadrilateral. So it's 10 centimetres times by 6, because this is the height. Okay, so 10 centimetres times 6 centimetres is, of course, 60 centimetres squared. Okay, and there we go. I've got the area of my parallelogram. Now, your work today is all about these things. So have a go at solving the area of different compound shapes, of different triangles and different parallelograms, remembering the different formulas. The area for a simple quadrilateral, for a triangle, and for parallelograms. Have a wonderful task, Year 6, and I will speak to you soon.